Neuromorphic computing is a big deal for AI, but what is it? Let's find out.
We often talk about how traditional computing is reaching its limit. There's a threshold we can't move past without making some seriously big changes to the way we structure computers. One of those exciting ways is by making physical computers a little more like human brains.
Wasn't that the original blueprint? Yes, it is. It always has been. What your brain? You're confused, just like staring into the abyss of your dress. Okay, it's confusing.
We introduced this concept in more detail here, but a quick recap, this kind of computing is called neuromorphic computing, which means designing and engineering computer chips that use the same physics of computation used by our own nervous system. This is different from an artificial neural network, which is a program run on a normal computer that mimics the logic of how a human brain thinks. Neuromorphic computing, the hardware version, and neural networks, the software version, can work together because as we make progress in both fields, neuromorphic hardware will probably be the best option to run neural networks on. But for this video, we're going to focus on neuromorphic computing and the really exciting strides that have been made in this field in the past year. See, traditional
I can't
computers
wait.
think in binary. Everything is either a 1 or a 0,
Exactly.
a yes or a no. You only have two options, so the code we use and the questions we ask these kinds of computers must be structured in a really rigid way. Neuromorphic computing works a little more flexibly. Instead of using an electric signal to mean 1 or 0, the designers of these new chips want to make their computers' neurons talk to each other the way biological neurons do. To do this, you need a kind of precise electric.
Okay, what she just said is a pipe dream, like this pipe that burst and now it's on fire. What is this? And look, okay, this is the eyes of disappointment. She knows that believing in this is a big disappointment.
Current that flows across a synapse, or the space between neurons. Depending on the number and the kind of ion, the receiving computer neuron is activated in some way, giving you a lot more computational options than just your basic yes and no. This ability to transmit a gradient of understanding from neuron to neuron and have them all working together simultaneously means that neuromorphic chips could eventually be more energy efficient than our normal computers, especially for really complicated tasks. To realize this exciting potential, we need new materials because what we're using in our computers today isn't going to cut it.
That's right. It's not going to cut it. They need the actual flesh. That's right. They need the actual flesh because you cannot recreate the ultimate creation. No, you cannot.
The physical properties of something like silicon, for instance, make it hard to control the current between artificial neurons. It just kind of bleeds all over the chip with no organization. So a new design from an MIT team uses different materials, single crystalline silicon and silicon germanium layered on top of one another.
I'm not impressed. Look, single crystalline silicon. Wow. And silicone germanium. It doesn't look like a flower. What is this? Is it German? Probably. It's probably made in Germany. Yeah. This just looks like one of those music pads. You can create really cool beats on these, okay?
Apply an electric field to this new device, and you get a well-controlled flow of ions. A team in Korea is also investigating other materials. They use tantalum oxide to give them precise control over the flow of ions, and it's even more durable.
Okay, so even if you can recreate that mechanical aspect, what makes you okay? A synapse in the brain fires, but it fires, and you can try to mimic that firing and receiving of that impulse or those anions or whatever. Listen, how then do you determine which ones fire and when and how it's just no, there's no algorithm, there's not. And these, x's are proof of that. Look, I don't know why, but they are. Okay.
Another team in Colorado is implementing magnets to precisely control the way computer neurons communicate. These advances in the
Wow.
actual architecture of neuromorphic systems are all working towards getting us to a place where the neurons on these chips can learn as they compute. Software neural networks have been able to do this for a while, but it's a relatively new advancement for physical neuromorphic devices. And these experiments are showing promising results. Another leap in performance has been made by a team at the University of Manchester, who have taken a different approach. Their system is called Spinnaker, which stands for Spiking Neural Network Architecture.
Oh, spin knacker, spin maker, spin doctor. That's right. And this person can't wait. It's all exciting news.
While other experiments look to change the materials we use, the Manchester team uses traditional digital parts like cores and routers, connecting and communicating with each other in innovative ways. The UK researchers have shown that they can use Spinnaker to simulate the behavior of the human cortex. The hope is that a computer that behaves like a brain will give us enough computing power to simulate something as complicated as the brain, helping us understand diseases like Alzheimer's. The news is that
Wow. This person has just said that computers, yeah, they eliminate, right? Um Based on yes and no determinations, right? Parameters, right? But how can that solve cancer? People can't solve cancer because it's not real. No. It's a disease of the spirit. Okay, you are the fleshly symptom of an overall spiritual battle. Okay, and no amount of wires are going to save you. As much as you like to think that plugging all these into your vertebrae is gonna, you know, save you, well, go ahead.
Spinnaker has now matched the results we'd get from a traditional supercomputer. And this is huge because neuromorphic architectures offer the possibility of higher speed and more complexity for less energy.
Again, selling you the idea that higher speed, complexity, and less energy are benefits from engaging in this, totally smashed, totally obliterated, bearing of life. Okay, this person is smashed, or just parroting a script that, you know, she has no clue what she's saying. She has. I don't even know if she knows where she is. Come on, she can't know. Uh, of course she knows. She knows exactly what she's doing. Okay, absolutely. She's a professional, guys. Okay, so she knows.
Cost. And with this new finding, we see that they're edging closer to the best performance we've been able to achieve so far. Overall, we're working towards having a better understanding of how the brain works in the first place, improving the artificial
Right. You don't even know how the brain works, but yet you're claiming to be manufacturing it. Wow.
materials we use to mimic biological systems, and creating hardware architectures that work with and optimize neural algorithms. Changing computer
That means nothing. You said nothing. Optimized algorithms. Wow. You could have just said, um, you could have said anything, and it would still mean nothing because it's not real.
hardware to behave more like the human brain is one of a few options we have for continuing to improve computer performance and to get computers to learn and adapt the way humans do. While scientists make computers that work like brains, put your brain to use by building your very own website. Domain.com is awesome,
Oh,
affordable,
selling.
reliable, and has all the tools you need to build a new website. They can fulfill all your website needs. They offer .com
Okay.
and
Are you
.net
gonna say
domain
something
names
at the
and
end? Okay,
intuitive
yeah.
website builders.
Let's get to
They
it.
have over 300 domain extensions to fit
Get to it.
pizza. Take that first step in creating an identity online and visit domain.com. It looks like it's going to be a wild ride ahead, you guys. I think you should probably subscribe to Seeker so that you can always know when something
Again,
new and exciting is picking
no
path.
resolve.
Neural
Just left
networks. Thanks for watching.
this person said nothing. And she knows it. Look, she's almost like, again, this is the look of approval. She knows she just said nothing. And that's the look. Nothing. Neuromorphic computing, right? Just more word salads for what, AI is and how it's moving forward. The only thing that's moving forward is how they're coming out with it more. Meaning you have to believe it first. If you believe it, then you're smashed. And of course you believe it because you get excited just like this, and then you fake smile just like this as well. Turn away from that and, forgive and love. Ask for the love of your creator, and you shall have it. Abide by the only way and not this way. What is this way? What is this? This is smashed, okay? This is confusion. Look, she's telling you it's confusing. It's string theory. Look, it's too complicated. You won't even understand it, right? Look, she's telling you you have to believe her. Believe her. Believe her. Believe her. Yes, believe me. Look, I have a watch. Watch. Believe me. Me. And people go into these fields, okay? That's what's sad. You go into these fields because you were a gamer and you wanted to pump code and make like this virtual reality, right? Because that's what you did growing up, escape your reality because your parents weren't there and they didn't love you. They didn't love you. That's right. It hurts to hear, but it's the truth. Any parent who lets their child be lost in the abyss, that's horrendous, okay? And of course, they're programmed by people like you because, of course, they have shows for children that say the same thing, but in a more sinister, effective way for the young, right? Because no child left behind. No, no child left behind. They need them. Remember, they need them, the children, and they will take them away from you if you cannot raise them accordingly to the programming that they seem and deem um adequate. All right, you're an inadequate parent. No, not because of your dependency and attachment and emotional way of living. No, not because of that, but because you're unfit. Because you can't have a job. Because you don't have a job and you don't have enough to buy your baby what it needs because it needs you to buy it things, okay? And you are not responsible, right? And this person will tell you right off the bat. In fact, I think that's going to be the next video, okay? I'm going to look up what a thought has to say about right, um raising children. Okay? That would be amazing. Can't wait. Okay, I'm going to end this now.